All right, let's jump right in. We hear the term artificial intelligence thrown around constantly, but how does a machine actually learn anything? Well, turns out one of the most popular ways is kind of like how we learn, with a teacher. And that's exactly what we're going to break down today, something called supervised learning. So yeah, that's the big question, isn't it? How does a machine possibly go from being, a blank box of circuits to making these incredibly smart predictions? I promise you, it's not magic. It's a process, and it's a really fascinating one. Here's the secret sauce. Just imagine you're studying for a huge exam, but for every single practice question, you're immediately given the perfect, correct answer. That's really the heart of supervised learning. The AI is being supervised by a teacher who already has that perfect answer key. Now, in the AI world, this answer key has a proper name. We call it labeled data. It's just a fancy way of saying it's information that's already been tagged with the right outcome. The label is the answer we want the AI to learn how to figure out on its own. So the whole learning process is, at its core, surprisingly straightforward. Let's say we want to teach an AI to know what a cat looks like. First, we show it a picture of a cat. That's our data. Then we give it the label. This is a cat. And we do this over and over and over again, thousands of times with cats, with dogs, with birds, whatever. The AI's whole job is just to find the patterns, the pointy ears, the whiskers, the tail, that connect that picture to that label. Okay, so once it's trained up on all this labeled data, the AI becomes this super useful tool for solving real-world problems. And pretty much all of these problems fall into two main buckets. Getting this difference is absolutely key because you have to ask the AI the right kind of question to get a useful answer. Let's look at the first one. So the first type of problem is something called classification. Honestly, the easiest way to think about it is like a sorting game. The whole goal is just to put something into the correct box or category. Simple as that. At the end of the day, a classification model is just answering the question, which category does this thing belong to? Is it option A? Is it option B? Maybe even option C? The critical thing to remember is that the answer is always a choice from a fixed, preset list. And here's the cool part. You're already using this stuff every single day, maybe without even realizing it. Think about your email inbox. It's constantly playing this game, right? Is this email spam or not spam? That's classification. Or when you're tagging photos, yep, that's classification too. It even does incredibly important things, like in medicine, helping analyze a scan to see is it cancer or no cancer. And banks, they use it to figure out if someone's likely to repay a loan or default. See the pattern? In every single one of these, the AI is just picking a label from a small set of choices. All right, on to the second type of problem. We can call this one the prediction game. Its technical name is regression. And this isn't about sorting at all. This is all about forecasting a specific number. The question a regression model answers is completely different. It's not which one. It's how much or how many. See the shift? We're not looking for a category anymore. We're hunting for a specific number. And again, you see this everywhere. Predicting tomorrow's temperature in degrees, that's regression. Forecasting how many runs a cricket team might score in a match, also regression. Or a business trying to guess exactly how many widgets they're going to sell next quarter. And of course, a huge one, predicting the price of a house based on things like its size and its neighborhood. This is the kind of answer you get from a regression model. It doesn't just say expensive or cheap. No way. It gives you a specific number, a concrete prediction that you can actually work with. It's predicting a value somewhere along a continuous line. So let's just put them right next to each other because this is the whole shebang. Classification asks which category, and it predicts a fixed choice, like spam or not spam. Regression, on the other hand, asks how much, and it predicts a continuous number, like a price or a temperature. If you mix these up, you get useless answers. It's like asking for a house price, and the AI just says big. Not very helpful, right? If you only remember one single thing from our chat today, let it be this. It's the simplest way to figure out what tool you need. Is your problem about sorting things into groups? You need classification. Is it about predicting a specific amount? Then you need regression. Honestly, understanding that one difference is the absolute first step you need to take before you can build your own real-world AI models. So, now that you've got the theory down, are you ready to actually give it a shot? Because, let's be real, the absolute best way to really get this stuff is to go from just watching someone talk about it to actually getting your hands dirty, to take these ideas and apply them to some real data. And if you're thinking, yeah, I'm ready for that, then I've got your next step right here. The Skill Development Center at the University of the Punjab offers a fantastic short course on AI. It's held right on the Quad-e-Azam campus with on-campus classes that are focused entirely on hands-on practice. You'll get the data sets, you'll get the tools, you'll get to train your very own models. It is without a doubt the perfect way to bring everything we've just talked about to life.